Sorry. Hi everyone, welcome to Java Fever. In previous video, we have already seen how can we create thread with the help of the callable and runnable interface, and how can we store the value with the help of the future. Okay, uh, when you are creating the thread with the help of the callable interface, so we'll try to understand future and computable future in this video. So it may take some time to understand everything. So we are going to touch core concept of future and computable interface, and we'll see coding wise also. So how can we create and how can we execute task with that of the this call future and the computable future. So let's start. So we'll touch this topic, what is future interface, creating future interface, how can we create, okay, and what is computable future, creating computable future and composing computable future, handling exception in computable future, okay, difference between feature and a computable future interface, and coding question we will see at last. Okay, so we are going to touch all this. So future interface, let's start. So in Java, the future interface is a part of java.util concurrent package, and it is used to represent the result of an asynchronous computation. It provides a way to manage tasks that asynchronously and retrieve their result when they become available. Here are the key points about the future interface. So it is available in java.util.current package. Okay, so it got introduced in Java 5. Okay, asynchronous computation future represents the result of asynchronous computation, typically a task submitted to an executor service for execution. Okay, in last video we seen that means the when you are creating the when we are getting the executing the thread with the help of the executor framework. Okay, so there we have to pass the instance of the callable interface, and then it will return the future type. So we are using future interface to store the result. Okay, so life cycle management, it allows you to check if the computation is complete, is done method, and is wait for it completion get method. Okay, so in future method we have is done method. Okay, so it will check that it's completed or not, your task is completed or not with the help of the thread. Okay, and we have a get method also to check the value of the future. Okay, and it will lock your thread till completion of your task. So this is the disadvantage of the future. Okay, because it will not allow to execute another thread because you are using the dot get, that means the it will wait till the completion of your task. So blocking method, the get method is used to retrieve the result of the computation. If the computation is not completed when get is called, the method block until the result becomes available. Okay, just now we discussed that means that it will wait till the completion of your task because you're using get method. So this is also one disadvantage of the future interface. So when you will understand the computable future, so it will be replaced. So disadvantage will be not available because of this disadvantage. Future computable future will be introduced. Exception handling: if the computation encounters an exception, it can be accessed via the get, okay, method, when which throw an execution exception encapsulating the underlying exception. Okay, and cancellation, there is a basic support for cancellation. Cancel method is there, but it's typically not widely supported across all implementation. So there is, I think, three methods. One is done. Okay, second will be the get, and third will be the cancel method inside. So cancel method to cancel your task. Cancel method is done method, and get method. So cancel, we used to cancel your current task. So let's start. Next one, limited composition. While Future provides basic methods for managing the completion of asynchronous task, it lacks fluent API for composing multiple asynchronous computation in a non-blocking manner. Okay, so it's not possible with that of the future. It's not possible that to execute in non-blocking scenario. Okay, non-blocking scenario means the firstly it will try to firstly future will try to execute your task, and then it will allow to execute another task. Okay, so it's not possible to execute in non-blocking manner, so it is possible in blocking manner only. It will block your task once. When it will be completed, then it will allow to execute your next task. So creating future, so how can we create future interface, we will see in this. So try to understand this code. So this is the very easy code. So I have implemented one callable interface to make one custom thread class with the help of the callable interface, and type is string here. And we have call methods, so implemented return, normally returning the one string here. So this callable interface created the instance for this callable interface, and then and created the executor service, okay, with the help of the two thread fixed pool size, and executing with the help of the executor submit task, okay. So we are using submit to execute a task which is created by you, which is created by callable interface, okay. And we have message. So here what we are using here, future. So what we are executing with the help of the executor dot submit method. So the result will be stored in future, okay. So the type of our reference variable of message is future. So we can get this value with the help of the message dot get dot to string, okay. So to string, that means that we are fetching the string value, so we put it. So what message get is a method of future interface to fetch the result of your future, okay. So let's move for next topic, completable future. So we'll try to understand what is completable future, okay. So completable future provides a powerful and flexible way to write asynchronous non-blocking codes, okay. Just now we seen, previously we seen blocking, okay, blocking, because future allow is blocking code, okay. So it will block your code, and it will not allow to execute next thread before completion of your current thread. But in computable future, what is it is possible to do asynchronous call, asynchronous with the help of the non-blocking code, okay. It will not block your code. It was introduced in Java 8 and has become popular due to its ease of use and ability to handle complex asynchronous workflow. So nowadays it is very popular. Most of the people are using computable future. Okay, so it is the most important topic according to the interview. So they will ask what is the difference between the computable future and future. Okay, so computable future is a class in Java concurrent package that implements the future and completion state interface. So if you see the code of the completable future, so computable interface, so you'll get that means that it's implement the future interface and completable state interface. uh, let's quickly see the how it is, how can completable future, if you see completable future. So this is the code of completable future. Let's check. So it's implement future and completable state. So in future, if you see, so we have some method, okay. So we have some method which is cancelled, is done, and get, okay. Just now we discussed is done is there, is cancelled there, and we get is there. So get, we used to get the value, okay. So see implements future and it implements completion stage also, okay. Because of this we can do the chain operation, okay. Like we have see, we can see we have then apply async, okay. We have then accept async, okay. So we have various method, okay. So future completable future completable future interface implements future interface and completion stage interface, okay. So let's move to our next topic. So it's represent the future result of the synchronous completion. It can be through a container, it can be through a container that holds the result of a synchronous operation that is being executed in a different thread. It provides a number of methods to perform various operations on the result of async computation. Let's move on next topic, creating a computable future. So how can we create a computable future? So we'll see quickly, okay. To create an instance of a computable future, we can use the static method which is supply async. So we have a supply async method which is available in future. So this is a static method, so we can directly call with that of the computer future dot the supply async method, and inside that we have to pass callable interface method. We can implement a callable interface with the lambda expression we can also do, and we can pass the instance of any callable interface provided by completable future class, which takes supplier as a argument. Okay, supplier is a functional interface that takes no value and returns a result. So it takes supplier as a functional interface that takes no value and returns a result. So this will be the way by which we can create computable interface, computable future. Okay, so in this is the future we are here storing with the help of the computable future. Okay, so what we are doing, a computer future data supply async, and we are passing here returning hello from computable future. We are returning here inside, it is taking the callable method, callable interface. So it's returning here string. So future is also a way to do the synchronous programming. Okay, and computable future is also is way to do the computable to asynchronous programming. Okay, but problem is there, that means there is some problem in future class, future interface, and some advantage is there in computable future. So basically we try to use computable future instead of future interface. So this is the way by which we can do. So what will be the output in this scenario? We are getting future dot get. Okay, so our output will be a hello from computable future. Okay, so like this we can create. So we'll see coding also. So we are trying to understand how can we create, so it will be easy to understand at the time of coding. It will not take more time to do everything. So composing computable future. Okay, so we can compose computable future. So how can we do? So see, one of the powerful feature of the computable future is ability to compose multiple asynchronous operation. We can use method then like we have then apply, okay, then combine, then compose, okay, to perform operations on result of computable future and create a new computable future as a result. So this is the advantage of computable future. It is not available in future interface. Okay, so we have a method. Okay, after getting our result we can do some we can perform further operation. I think we have various method, 10 to 15 methods. We can see one by one. We'll see important method, and remaining things you can do by yourself to understand easily. So how can we do here what we are doing to, we are composing. So I have created three hello future. Okay, with the help of supplying hello and greeting future. Okay, what I'm trying to do here, combining both the future with the help of the hello future. Okay, this is the first one, and then combine greeting future, and this will take function as a argument. They are providing m1 m2 and m1 plus m2. We are combining it, so our output will be like hello world. So this is the concatenation. So our output will be hello plus world, hello world. So like this we can compose with that of the computable future. It is possible, but it's not possible in future interface. So let's move for next. This creates two instances of the computable future that returns hello and world. Okay, so the first will be hello and second will be world. Then combine the result of both the computable futures are concatenated and result as a final result. So here it's a combining. So hello future dot then combine method is available. Okay, it's, and then we are combining here. Let's move for next topic, handling exception. Yeah, it's possible to handle exception in computable future. So we'll try to understand how can we do. So computable futures provide method like exceptionally. So this is the method exceptionally. Here we have written, already written. Okay, and handle to exceptionally, and handle exception and errors that might happen during asynchronous computation, and a provide fallback value to or perform some alternative operation. So here what we are providing, if we get this exception like supply.async method we are calling, here we'll get the arithmetic exception because we are dividing 10 by 0. So we will get the arithmetic exception. So when we will get a exception, so our result will be 0. We will not get any exception. Okay, so if you print this result get dot result future dot get, so you will get output 0. Okay, because of this exceptionally method, we are getting 0 instead of error exception. So this is a feature of a computable future. So it is not possible in future interface. So let's move for next topic. Next thing, inside supply async, when 10 is divided by 0, it will throw arithmetic exception, and control will go to exceptionally block n, which is return, which in turn return 0. Okay, so just now we explained everything, so it's the same. Let's move for next topic, which is difference between future and computable future. This is most important topic according to interview. So we'll try to understand one by one. In future interface, okay, represent the result of a synchronous computation. Extend future with more future for asynchronous programming. Okay, so we can also do asynchronous programming with the help of the future interface, but there are some more features with the help of the computable future. Just now we seen we have chaining method, we can combine, okay, we can do then apply. So and blocking operations, so get is blocking. So if you use get method, so it will block, it will allow only one thread to execute at a time. Okay, so once it will wait till completion of your first, then it will try to execute next task. Okay, that thread will execute next task, so your thread will be blocked till completion of your task. Okay, supports non-blocking composition. So we have then apply then compose etc. Okay, so with that we can do non-blocking composition. And completion handling, this is the completion handling. So limited support for handling completion or error. So we haven't more features to handle exception, like just now we seen, okay, in previous video we have exceptionally. Okay, so this feature is available in computable feature explicit method, like complete exceptionally handle. Okay, so this this method we can use to handle the exception for handling result and exception. Okay, composition, limited chaining and composition. Just now we seen we have 3 to 4 methods in we in future interface, but we have, I think, we have various methods, chaining method in computable futures for the better asynchronous programming. Okay, Fluent API. So error handling, exception thrown by get method. Okay, and handler and exceptionally method, error recovery and handling. Okay, so exception, this will throw the exception, get method, and handle and exceptionally method for error recovery and handling. So just now we seen with the help of the exception we can handle the exception. We can with the help of the handle also we can handle exception. Non-blocking API, no explicit support for non-blocking API, and supports non-blocking in completion when complete and then accept. Okay, so we have method to do non-blocking completion with the help of completable future. Combining future limit, like get limited support. Okay, like if you see we use get, then it will be blocked. Your thread will be blocked till completion of your task. Okay, but we have then combine then accept both. Okay, for combining result of multiple features. Just now we seen then combine, so they so we combine the result of first feature and second feature, and then we got the result hello world. So it is possible in computable future. Timeout cancellation, no explicit support for timeline cancellation, and support setting timeout or timeout complete on timeout and cancellation cancel. Okay, so we have support for this timeout and cancellation also. API flexibility, basic API for asynchronous result, basic API for asynchronous result. So we have basic API and enhanced API for asynchronous programming with advanced feature. Okay, so we have enhanced feature in computable feature. So I think we have discussed everything. We understood the core concept of future interface and computable future interface. So now we are going to do some coding part so that you will understand easily. Let's start the coding. We'll try to understand everything. Okay, so I have taken one class. Okay, computable future examples. So there I'm going to create the executor service quickly. Okay, executor service equal to executor executors dot executors is a class. Executors dot, this is a class available in concurrent dot new fixed thread pool you can use. Okay, so we are creating 10 thread inside the thread pool. So we'll try to quickly service dot, we have submit method. Okay, in submit method we have callable runnable task also, so we will use commit method, and here we'll write one lambda expression quickly to understand so how future works. So here we are going to write call method which is inside the callable. So we are using the lambda expression, so return future hello from future. Okay, so this is completed. So now we'll try to do service dot submit. So already service dot submit is already we did. Okay, so it will store some value. So what will be the, where it will store, so we have to provide future. So future we have to store, it will store. So future, yes, right, it will right. So we have to import this future, and the return type you can also sign string. Okay, because you are returning a string. So let's print the value future dot get. With the help of the get, we have like methods like get is done. Okay, it's cancelled just now we seen. So future dot get, so we can fetch the value of a string. Okay, future dot get. So we have to throw the exception, we can throw the exception to throw the declaration. Okay, so we have interrupted exception and execution exception. So let's print the value sys out. Print the value of future dot get. Okay, what we are getting in future dot get, we'll try to print here, and let's see the value future value. Okay, going to run quickly. I'm going to clear the console and run as Java application. Okay, hello from future. So we are getting, so what we did here, so created one executor service with 10 fixed thread pools. Okay, and we are trying to use submit method with the help of this executor service. Okay, and we are returning hello from future one string, and we are storing with the help of the future interface. So we can do synchronous programming here with the help of the future, but we haven't chaining method to do combined. Okay, or then apply with same like computable future. So it is not possible. Okay, if you want to combine, so it is not possible. Like let's try. Okay, so like we have a future. So if you do can future, you can do future 2 and future 1. Okay, if we'll try like, so future 1 is there. Okay, because that you are getting exception. So future 1 dot. Okay, so if we'll try, we will not get any like then combine method like this. Okay, so we haven't any chaining method, we can't combine anything after the execution of your future. Okay, but it is possible, you can do in future computable future interface. Okay, so this so because of this, computable future got introduced in Java 1.8. So let's do with the help of the computable future. Here I'm going to use computable future. Okay, I'm going to use computable future. Yeah, see, and com, com future I'm using here. Okay, com future 1. But what we can do here, we can't use the service method. We have what we have. So we have methods like, we have to computable future, we have method, we have supply async method which is static method just now we discussed. Okay, so computable future computable interface we have to call and then supply async. Okay, we have, so here we can provide any supplier. So we are going to write here one callable, same like we are going to write same logic we have just now we have written it here in submit. Okay, copy and paste. Yeah, so hello from computable future, or we can write here hello. Okay, so hello we are going to write, so going to print the value. Okay, so sys out computable future dot get. So let's run and check what we are getting here. Computable future, so let's print computable completable completable not, so this spelling should be correct, I think it should be correct. So this should be completable future. Okay, so let's run and check what we are getting. Yeah, we are getting hello. Okay, so with the help of the computable future we can also do asynchronous programming, it is possible. Okay, same like future, but we have some added advantage, we have some added features. So we'll try to see in this video. So what we are going to do here next, we are going to create another computable future. Okay, so we are going to do computer future 2 and we'll try to combine. Okay, so supply a scene hello, here we are, I'm going to return world. Okay, so we have computer future 1 and computer future 2, so I'm going to combine both. Okay, let's print. Okay, let's print alone and then we'll try to combine both. Okay, so now it should be here world, so let's print world, run as Java. Yeah, hello we are getting hello. Why we are getting hello? Because we are not printing computer future 2, we should print computer future 2 here and then try to run again. Okay, so what we are getting here, we are getting world. Okay, so we are getting hello and we are getting world with that, with the computer future we are getting. So now we are going to combine both. Okay, so it is possible with the help of computable future, completable future. Okay, so computer future 1 dot, we have methods. Okay, like accept, either apply, okay, cancel, complete. Okay, so we can see one by one. Okay, so we'll touch only the important method and you can do some R&D and you will get some idea. So we are going to combine, then combine we have overloaded method we have, so we are going to then combine, going to use say by function and completable stage we can pass. So we'll pass, going to combine 1 with 2, so we'll do here 2 computer future 2 and then function like m1 m2. What we are going to do, perform, we are going to concatenate m1 and m2. So we are going to concatenate m1 m2, so here we can provide one space. Okay, so we'll get hello world. So try to store inside completable future. Okay, completable, so what was, so sorry, completable future combine a future. Okay, so let's try. So what will be the type, the unique type string, so make it a string. Okay, and then print it, sys out. Okay, print combine future. Let's print and check what will you get. Okay, going to run as Java application. Yeah, completed normally. Okay, so I think we have to use get method to get the string. Okay, so we are using get method. So let's run again, because we are getting hash code here. Yeah, we are getting hello world. So it is possible to combine two compatible features. Okay, with the help of the uh, we have methods like then combine. Okay, and we have another method. We also try to we have then apply. I think then apply. So we can also do some operation. Okay, like then apply. So we'll do quickly. We'll try to use then apply also. Okay, so we have combine future. Okay, and combine future dot then apply. Okay, so it will take function. It is a overloaded method. So async, that means the it will use multiple threads. Okay, and apply. So function, so it's take function. So what we'll do, we'll try to modify, like we have x and we are doing x plus what we are trying to do here, mapping. We are trying to do mapping. So we have already hello world. So hello world, so we can do like welcome to, yeah, or hello world x. We can make it hello world FRIEN friends. I'm going to write here hello world friends. So okay, so we have already got the combined future. Okay, so they there we are going to add some more value. Okay, so it should be hello world friends. So let's check it's working or not. So we have to store this value inside any immutable future. So make it then apply a future. Okay, so let's run it's working or not. So sys out and then apply. So let's run. We'll check what is the output. Yeah, so here we have to put get method, then we'll get, I think. Let's run again. So ping, yeah, hello world friends. Yeah, so it's possible with the help of computable future. Okay, so this is the advantage of computable future, because nowadays people are using computable future for asynchronous programming. So like this we can do. I think you understood everything. So if you have any doubt, so you can comment and we can discuss on open platform. So hope you are loving my video. So if you're loving my effort, please like, share and subscribe. Thanks everyone for watching, and bye everyone.